We have a particle under motion with velocity v described as x squared plus 10x plus 3. What we want to do is change the variable of this so that instead of the velocity as a function of x, we have it as a function of time. One way to interpret this question is to view this as a differential equation, a one-dimensional differential equation where the dx dt is equal to this polynomial. Here, we can separate the solution using separation of variables, something you can learn in calculus too, getting the x's on one side and the t's on the other. When you integrate it, the t's get very simple, t plus constant. The left side will be a little bit more difficult. To make the left side a little easier for us, we're going to change the polynomial to make it a difference of two squares. We know that x squared plus 10x plus 3 is equal to x plus 5 squared minus 22. You put that on the bottom, and if it's a common integral theme, this theme being 1 over a squared minus u squared integrated with respect to u is equal to the natural logarithm of that ratio, as you'll see in just a moment. And this is very useful because it can give us a very fast mathematical answer without having to dive too deep into it. In physics, sometimes we're not totally interested in that. So we can simplify our x side of the equation by this expression, 1 over 2 times the square root of 22 times the natural logarithm of the square root of 22 plus x plus 5 over natural square root of 22 minus x plus 5 parenthesis. Now from here it's going to be a bunch of algebra, and you can see right there I actually messed up on my signs, so make sure to be very careful on that. The minus is on top, the plus is on bottom. You want to be very careful of this. I'll go through the first expression where I'll take each side to the an exponential of each side. The logarithm cancels out on the left, and on the right it puts everything up to an exponential. And I'm going to go ahead and use an equation solver to solve that, as you can see on the screen right now. And you can see this expression is very long, quite nasty, and not exactly our answer. It is part of our answer. Our answer is actually equal to x squared plus 10x plus 3. So in order to get our answer completely, we have to take this quantity, square it, add 10 times that quantity plus 3, and this will give us our final answer. As you can see, it's this big long expression. We can simplify it a little bit more using a calculator. You can use a calculator such as Wolfram Alpha to do this, and we get this expression. Now say we wanted to check to see if this was right, one thing we can do is take the derivative of the original position. If that derivative matches the velocity, we did right.